All right, ladies and gentlemen, last video for the week. We are on what I consider section 12.6, and this is going to be on secants and then other couple special theorems involving segments and circles. So, segments of chords. Remember, a chord has its endpoints on the circle. So our theorem here tells us if you have two chords that intersect on the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of another chord. So what we have here is that EA, this piece, times, we're going to say EB, is equal to EC, this piece, times ED. So it's just the two little parts there. Okay, so it's like part times part is equal to part times part of my other one. Okay, so let's do an example here. It says find the measure of ML and JK. So I'm going to come over here right away and do ML equals and JK equals, because at the end we're going to have to go back and plug something in. So when I look at this for my parts, if I look at this piece right here, I've got that is one side is x plus 1, and I need to multiply that by the other side of x plus 3. All of that is going to be equal to our other one that we have here. I've got x times x plus 5. So we're going to have to distribute and FOIL all of these. Here this is going to give me x squared. It would be plus 3x plus x is equal to, over here I'll get x squared plus 5x. And I forgot something here, because first outside, inside, and then last. This should be a plus 3 as well. Okay, so this is going to leave me on the left-hand side, x squared plus 4x. If I combine like terms, plus 3 is equal to x squared plus 5x. Notice that if I move an x squared over, those are gone, which is really nice. And if I move my 4x over there, I'm going to go minus 4x, I'll end up with just x is equal to 3. Okay, so we've got to be careful here. If I want to find ML, and I'm going to erase this here. ML is this little segment in purple plus the squiggly one. So when I plug a 3 in right here, 3 plus 3 is 6. So I'm going to say it's 6 plus that additional piece is x plus 1. 3 plus 1 is 4. So ML is equal to 10. For JK, I've got to take this piece in purple, which is x plus 5, so that's going to be 8, plus just this little piece right there, which is x, so 8 plus 3, we get 11. So there are our two answers. Okay. Our next theorem talks about segments of secants. So secants are hitting in two spots on the circle, and it's just a line instead of a segment like a chord. So this one is a little more complicated. It says if two secant segments share the same endpoint outside of a circle, so I've got them meeting out there, then the product of the lengths of one secant segment and its external segment equals the product of the lengths of the other secant segment and its external segment. Okay, so external segment is the key thing here. I have two of them. I have the one in purple and then this one in red. Oh, come on, don't do this. Oh. Okay, let me kill one note and fingers crossed this opens up so I don't have to start the video over. There we go. Okay, so for my external segments, like I said, we've got this one and this one. Okay, so the theorem says the whole segment times the external segment. So this whole segment right here is going to be EA times EB is equal to EC, my external segment, times the whole thing, which is going to be ED, that entire piece. So you can think of this one as outside piece, PIECE, times whole, is equal to, same thing, outside piece times whole. Okay, so if I want to find the value of x on this one, we've got the outside piece, so I'll start with this one right here. The outside piece is 6 times my whole piece is going to be this entire thing. Notice that that's 4 and 6 broken up, so that whole thing is 10. So I'm going to go 6 times 10 is equal to, now I'm going to do the next outside piece, which is 5, times the whole thing, which would be 5 plus x. So this is going to give me 60 is equal to 25 plus 5x. I'm going to subtract 25, which would give me 35 is equal to 5x. And we end up with x is equal to 7. Okay, next one is the exact, nope, just kidding. It's the second one. This first one isn't too bad. So this was our first theorem with chords. So this one is just taking the product of the two. So I'm going to go 5 times 12 is equal to x times 6, which is just 6x is equal to 5 times 12 is 60. X is equal to 10. So that one's pretty straightforward. Okay, number 2 is going to get a little more difficult, and we'll talk about why. So on this one, my external segment, or the outside piece, is 6. So I'm going to go 6 times 6 plus 8. It's going to give me 14 is equal to outside piece of 7 times. Now, if I want to represent this entire piece, I've got to write it as, I forgot. I want to switch something up here on this one. We're going to switch the 7 and the x. My bad. I made a note to do that, and I messed it up. So this is going to be x, and then this one is going to be 7. Because this makes it more complicated and more like the ones you guys will see on your test. So back to doing the outside piece x times. Now I've got to think about what is this entire segment length there. That would be x plus that 7. Okay, so I'm going to go 6 times 14 is 84. On the right hand side, when I distribute, I get x squared plus 7x. Okay, we have a quadratic, so what I'm going to do is say 0 is equal to, it's going to be x squared plus 7x minus 84. Now, you could sit and try and factor this. It does not factor. Okay, so what do we need to do? Got to go with quadratic formula. Okay, so remember that's a, b, and c are the values that I need to be thinking of, where my a value is 1 out front, the b value is 7, and my c value is negative 84. Okay, so I'm going to go x is equal to the opposite of b, so negative 7 plus or minus the square root of b squared. Now, I would highly recommend actually do that in your head, 49, minus 4 times my a value of 1 times my c value of negative 84. Now, a lot of you guys made mistakes on this on last week's assessment. Notice that you've got a minus there and a negative here. So that value is really going to be added on to 49. And some of you guys are making that mistake when you type it into your calculator. Okay, all of this we can't forget is over 2a, so 2 times 1 is 2. So let's go one step further. I'm going to have negative 7 plus or minus the square root of 49 minus 4 times 1 times 84. So if I go 4 times 1 times 84, because again it's going to be positive, this piece right here is 336, and it's 49 plus 36. So 49 plus 336 gives us 385. All over 2. So this branches off, excuse me, into two different answers. It would be x is equal to negative 7 plus square root of 385 over 2, and negative 7 minus the square root of 300, this should be 85. Oh my gosh, what a pain in the butt. If I hit cancel, this is probably going to lose all of our progress. Yep. Okay, let's try this one more time. Okay, so it didn't get rid of that much. So it was negative 7 plus the square root, plus or minus, excuse me, the square root of 385 all over 2. So I broke it up as negative 7 plus or minus the square root, or no, plus, man, this has been a bad video. So negative 7 plus the square root of 385, all divided by 2, or it's going to be negative 7 minus the square root of 385, all over 2. Now, keep in mind we're trying to find x here, which is a distance. If you look at this one right here, -7, and then you minus another number and divide by 2, that's going to come back negative. I can cross this one out right away. I don't even have to think about that one, okay, because it's just x all by itself. But the top one, if I take -7 plus the square root of 385, and then I divide it all by 2, you come up with an x value of approximately 6.31. And on this bottom one, like, you wouldn't have to know to cross that out right away, and I'm going to type it into my calculator real quick just so I can show you guys what that value comes out to be. That one comes out as like -13.3, which in the context of this problem does not make sense. Okay, so I would not include that answer. This would be the only one I want. Okay, got to know our quadratic formula. So this brings us to our last theorem that we need to learn, and that is segments of secants and tangents. So now I have a secant and a tangent. Remember, a tangent intersects that point on the circle, and it's only one point. As this continues, it never hits that circle again if you were to zoom way in on it. So this one says if a secant segment and a tangent segment share an endpoint outside of the circle, okay, so right there, then the product of the lengths of the secant segment and its external segment equals the square of the length of the tangent segment. Okay, so let's break that down. The tangent is EA, and notice how I'm squaring that. All of that is going to be equal to, this doesn't change from our last one, it's the external piece or the outside piece of EC, and then I multiply it by the whole thing, which is ED. Okay, so external segment times the whole piece. The only thing that's new on this one is that the tangent segment gets squared, okay, because there's nothing else that I can do to multiply it like we did here. Okay, it's just one segment, not broken up into two chunks. So let's do this one. Use the figure at the right to find JK. Or use the figure at the right to find RS. Sorry, I was looking at the wrong one. So on this one, here is my tangent segment. Theorem that we just looked at says to square that. So 14 squared is equal to, now I take my external piece, which is x, times my internal piece, or not internal piece, the entire piece, which is going to be x plus 12. So x times x plus 12. So 14 squared gives me 196 is equal to, this is going to be x squared plus 12x. As I move that over, I get 0 is equal to x squared plus 12x minus 196. This one, again, is not going to factor, so we're going to have to go quadratic formula. So I'm going to say x is equal to the opposite of b, so it's going to be -12 plus or minus the square root of b squared, which is 12 squared, so 144, minus 4 times my a value of 1 times c, which is -196. Again, notice that I've got a negative and a negative, so that's going to come back positive, which is going to give me 928 on the inside, and don't forget to divide by 2. Okay, so I'm going to have x is equal to -12 plus or minus the square root of 928 over 2. Just like the last example, the negative I'm going to throw out because it's -12, and if I subtract another number, it's still going to be negative. I'm finding just an x here, so in the context of this problem, it wouldn't make sense. The only one I'm going to keep would be negative, oh my gosh, this is annoying, negative 12 plus the square root of 928 over 2. And if we type that into a calculator, where do I have that written down? That comes out as approximately 9.23. Okay, again, throw out the negative because it wouldn't make sense in this problem. So I'd like you guys to pause it and try and do this last one on your own, see if you can get that, and then you can come back and check here. Okay, so again, I've got a tangent and a secant, so I'm going to take the tangent piece and square it, so 8 squared is going to be equal to, now I'm going to just write that so I can save a step here, that's 64, okay, which is coming from 8 squared is equal to your external piece, x times the entire piece, which would be x plus 6. So I'm going to get 64 is equal to x squared plus 6x. This is going to give me 0 is equal to x squared plus 6x. minus 64. This one again does not factor. No, it doesn't. So we're going to have to go quadratic formula. So I'm going to say x is equal to the opposite of b, so negative 6, plus or minus the square root of b squared. B is 6, so 6 squared is 36, minus 4 times 1 times 64, all divided by 2 times a, which is 2. Okay, 2 times 1 gives me 2. So I'm going to get x is equal to, it's negative 6 plus or minus. The inside of my radical comes out as the square root of 292 all over 2. On this one, again, the negative doesn't make sense because I'm just finding x. If it was like x plus 18, then maybe a negative would work as long as it came back positive. But since it's just x, I can ignore the negative. So what I've got to think is negative 6 plus the square root of 292 all over 2 is going to give me a value of approximately 5.54. And there we have it. So just as a quick little review, the three theorems we had secants and tangents. The one we just talked about, take the tangent squared is equal to external times the whole. Okay, our other one was if you have two secants intersecting outside, it was external times whole is equal to external times whole. And then we had our chords when they're intersecting on the inside. It was just piece times piece is equal to the other piece times the other piece. Okay, let me just double check. I got all the examples done. Yep, so here's your guys' assignment. We will see you later.